2.9 will be the last section that we do for this chapter. And I guess it would be the hardest one. It actually combines a couple of different things that we've learned earlier. So we're going to talk about something called combined and joint variation. How do you write a variation equation with more than one variable? So far, we've only talked about one specific variable, usually x, like y equals kx or y equals kx over k divided by x to the n. But now we're going to be adding some more variables, more than just one. So the first one is called combined variation. So this is when you have both direct and inverse variations that occur together in the same situation. So now we're going to have statements that say direct and indirect, or direct and inverse. The generic formula for combined variations, it is going to be y equals kx over z. Now this really is generic because you could have multiple variables on top, and now you can have multiple variables on the bottom, and you can have powers on top and the bottom. This is a very generic formula. It just depends on what they give you. So whenever they say directly means you're going to multiply. Maybe I should do this part. Direct means multiplication, multiply. And then as soon as they change to inverse or indirect, that means you're going to do the fraction bar and divide. It really just depends on what comes first, and then whatever comes after that is what you do with multiplication division. K will always be there. Nothing changes for that. And you just read it from left to right, and we change the letters out. So really this one can have all kinds of different answers, but we're just going to have things on top, multiple variables on top and on the bottom. It just depends what it says. So let's try one. Write an equation that represents a statement. All right, so R varies directly. So I'm going to start with the letter R. That's the first letter, so it comes first. R equals. Directly means we're going to do multiplication. So R equals K is always there, times whatever comes next. So R varies directly as the square of S. So that means we're going to multiply by S squared. And inversely, now we're switching it up. Now we're doing division. Divide as T. I don't see any powers on T, so it's just T. So that's practicing making the equation. These ones are a little more complicated because they have more variables. But you just have to remember, like, you read it from left to right, and as you read it, you write it. And don't ever forget K is always there. So this one means you had to multiply, and this one means you had to divide. We're going to try a couple other ones, see if we can get the hang of it. Y varies directly as R and inversely as the square of G. So it's saying we start with Y, and then we put K. Then after that you put K, keep reading and see what else you write. Varies directly, that means multiplication, times as R, no power, just R. And inversely, so now we're going to division, put a fraction bar, as a square of G. So G squared 2. That's it. Example 3, again, whatever starts with is the first letter you use, G. So we're saying G equals, and we might as well put K in there. K varies directly as W, so times W, and inversely, so we're dividing, as the cube of H. So H to what power? 3. Our example 4, D equals K. Really, as soon as you get the first letter, you could just write that down and then write equals K, because you're either going to multiply or you're going to divide. Directly, so multiply by Q, and inversely divide. So we did Q, inversely means divide, as J. Again, no powers on either one. So once you get the feel for doing this, then we can move forward with plugging in numbers and finding K and doing everything that we used to do. So we're going to try one, but it's going to be a word problem. So example 5. The hyperfocal length, H, in meters varies directly with the square of the focal length, L. I'll highlight some important things. We have directly, square, L and H, okay, in millimeters, and inversely, it's pretty important, with the selected aperture, F. I'll just circle these, all the important things. All right, part A, write the general variation equation. And all this stuff that here is talking about the hyperfocal length and aperture. A lot of this stuff is referencing a camera, like a kind of a professional camera. You can like change things like the aperture and the hyperfocal length, things like that. So as we read it, we write it. We're going to write the general equation. The hyperfocal length, H. So H equals K. Don't forget that. Varies directly. So multiplication. Directly with the square of the focal length, L. So L squared, which is 2. 2. In millimeters. Okay, so that's the unit on that. And inversely, here it is, division, with the selected aperture, F. F. All right, so we have the correct equation. Now we can use it in part B. Find the value of K. So we're going to find K up here. Now they're going to give us some numbers to plug in. When the hyperfocal length H is 10.42 meters, or I think it's millimeters. Wait, yeah, in meters. Okay, so this is H. I'm just going to label it. When we use a 50 millimeter lens, that's your L, and the aperture F is set to 8. F. So we're going to plug everything in, and we'll find K. So H is 10.42. Just copy down the formula up here. Equals K times L, which is 50, squared, over the aperture, which is 8. Now, how do we solve this? There's a couple ways to do it. One is we could get rid of the 8, because there's division here. We can multiply both sides by 8. That's fair. And then we could get rid of the 50 squared by dividing. You could also do 50 squared and then divide it by 8 and get a number, and then divide after that. You could do reciprocal. It doesn't really matter. I think I'm going to do the 2 steps in one. So I'm going to multiply both sides by 8. This is like 8 over 1. So the 8s will cancel. Then you're going to do 8 times 10.42. So if I go down here, we'll have 83.36 equals K times, and we can also do 50 squared. So what is that? 2,500. Well, I should probably write it over here anyway. 83.36 equals K times 2,500. And then how do you get rid of the 2,500? Since you have multiplication between the two, you would divide 2,500. And then this cancel out. So do 83.36 divided by 2,500. It's going to be a decimal. Looks like it'll be 0.033 344. I think we might as well just round this. Maybe I won't write this all out. Let's just do 0.03 and do I round it up or down? I guess that's fine. We'll do 0.033 maybe. It's a long decimal. All right, part C. Write the variation formula for this situation using your K values. This is where we combine the two. We have our original equation up here, and we put it with our k value. So that would be h equals our k value. I'm going to do 0.033 times L squared all over F. So this is our generic formula now for the situation. And then we're going to use it in the next problem. Find the hyperfocal length. So that's probably H, right? It says it up here. Hyperfocal length H. Needed if you want to shoot a 300 millimeter lens. So that would go in for, what's lens? A lens up here. It's your L value, focal length. It also says up here it's measured in millimeters. At the aperture setting of 2.8. Aperture is F. So we're going to find H. We don't know that one. So we're going to use this formula. Just plug in L and F. 0.033 times 300 squared. That's the L. And we're going to divide that by 2.8. So 300 squared, you can probably do the whole thing at once, is 90,000 times 0.033. So the top is 2,970. The bottom we're going to divide by 2.8. Looks like I got 1,060. And 0.7. And the hyperfocal length is measured in meters. M. That's it. So really it's just what we've been doing before. It just has a couple more variables to it. Takes a little bit longer in solving it. So if we backtrack up here, we had to multiply first to get rid of the fraction, and when we try to get k, and then we divide. So it's like 2 steps, and you end up getting the k value. Do the same thing as before, plug that back in the original equation, and then they'll give you some values to plug in for the other variables to solve. So that's called combined variation. The next one we have is called joint variation. So that is very specifically, it is direct variation, but it has more than one variable. So remember, direct variation just means all multiplication. You multiply stuff together. But now we're just going to have a bunch of things being multiplied together. So when it uses the word jointly, think of everything being multiplied together. But besides that, we still have the same stuff. We're still going to have k. Nothing else changes along those lines. So example 6, D varies jointly as f and g. So we'll start out with D equals k, don't forget that, times, jointly means everything gets multiplied together, f and g. F times g. So you're not going to have any division here. For example 7, g varies jointly, so g equals k times, jointly means multiplication, as a square of x and cube of h. X squared times again, h cubed means 3. No division. Let me see, I only have 2 left. All right, example 8, the area of a triangle varies jointly with the height and the base of the triangle. So write the variation equation. So we have to pick some letters here. The area of a triangle, so I'll pick A, equals, varies jointly, so we're going to be multiplying everything together, k times, with the height, I'll use h, and the base of the triangle times b. That's it. What is the constant of variation for the area of a triangle? It's asking you what's this k value. Really, there's no math involved in this question. Just asking if you know the area of a triangle, right? If you're trying to find the area of a triangle. it is the height times the base. And this value here, if you know it, to get the formula for area of a triangle, the k value is actually equal to 1/2. I don't know if you've ever seen the area of a triangle is 1/2 base times height, or height times the base, either one. So I was just wondering if you knew that one or not. No math involved in that one. Okay, we have one more left. Example 9. The volume of a solid with a circular base varies jointly as the height of the solid and the square of the radius of the base. Write the general equation to model the statement. All right, we have to pick up some variables here. So as we read it, we'll make some variables and create the equation. The volume of a solid with a circular base. Let's choose volume, V, equals, got to have K in there, don't forget that. Circular base varies jointly, that means multiply, so I'll put dots here. As the height, all right, that's pretty important, H, of the solid, and the square of the radius of the base. So squared is going to be radius, is going to be R, and then squared is 2. All right, so now they're going to give us some values to find K. If the volume of the solid is approximately 75.4 cubic centimeters, when the radius is 2 centimeters, and the height is 6 centimeters, find the value of K. So we just got to label these numbers now. Volume comes first, so it's saying the volume is 75.4. Radius is 2, that's R, and the height is 6, that's H. Plug it into this formula up here, and we'll find K. So it's 75.4 equals K times, what's H? 6 times R, which is 2. And don't forget, it's being squared. This one's actually not too bad, because we can actually put all this stuff together on this right-hand side, and then we'll get rid of it by dividing. So we're going to do 2 squared, which is 4, times that by 6. So 24 equals 75.4. Put a dot there. And then to get rid of the 24, with the k being multiplied together, we got to divide. 24's cancel, and then just do 75.4 divided by 24. And see what you get. Looks like it's going to be 3.1416 repeating. But I'll stop there. There we go. So that should look familiar, hopefully. The value of k is approximately equal to what famous math symbol? Math value. This is really close to what symbol? 3.14 is pi. And it should be. So actually, if we rewrite this equation up here with k in it, that's just saying that it's v equals, instead of k, it's pi, 3.14, pi times h times r squared. That does give you the volume formula for a cylinder. It says a solid with a circular base, but it's basically a cylinder here. That's what you have. So the k value in this formula is pi. So that is everything. I think I'm going to go over like 1 or 2 more things real quick. Then you guys can finish the rest of the huddle and mastery. Number 2. The formula F equals ma gives the force F on an object with mass m and acceleration a. All right, and part A. Rewrite the formula in words using the language of variation. So now we're going to go backwards. We're going to go from having the equation like we did back here. We're going to take the equation, but now we're going to write it out in words. So we go back. So what can we say? How are these being combined? Well, since it's being multiplication here, we would have joint, right? This would be jointly. So what does the F stand for? The force F on an object. So we can say the force of an object so that's the F letter. F, the force of an object, and we'll say varies. And what do you use to get those things multiplied together? We're going to use the word jointly. Varies jointly with what? What's M stand for? The mass. With its mass. And what else is there? A, which stands for acceleration. There we go. So that would be the sentence that you would use to get this formula. The force of an object varies jointly with its mass and acceleration. We don't see a K here. That actually leads us into part B. What is the constant of variation? The K value. Do you see one? I don't see a letter K up here. So that must mean there is a K value. We just can't see it. What number would it be if you cannot see a number in front of these variables? Well, technically, what is always there is a 1. So the constant of variation, even though you can't see it, K is actually 1. So that's kind of a hard one to figure out. There's always a K value. In this case, you just can't see it because it's 1. That would be what's in front of the M. And I also wanted to go over this one here, number 3. And then the rest I'll leave to you. Sonia calculated the volume of a cylindrical can of cat food. So now we're talking about a cylinder again. With a radius of 1.5 inches, that's R. Height of 1.2 inches, H. To be about 9.2 cubic inches. That should be the volume. Because cubic inches is inches to the third. Okay. Use the equation from before. This one we had originally. I think it was a problem or two ago here. Most recent one we did. To calculate the constant variation K. So you're going to plug in these numbers and find K. So the volume is 9.2 equals K times the radius, which is 1.5. That has to be squared times the height, 1.2. So I'm actually not going to do this problem with you. You can go ahead and square it, times it by 1.2, and then divide, and see what you get for K. Remember what this K should be, what we got last time. So if it doesn't come out to be that, then something went wrong. Not with you, but with this problem. This person, Sonia, must have calculated something wrong. So you're trying to figure out what does this value come out to be, or what it's supposed to come out to be, and see if it does. Then you can answer part B. Did Sonia use the correct formula, and how do you know? So you're going to check and see if it comes out to be what we said it was supposed to be in the last problem. So if you need help with that, just go back to example 9 and look at that one, what it came out to be. I think the rest of it should be fine. You can finish the huddle and the mastery, and that will be it for all of chapter 2.